The topic of this video is TensorFlow Regression. If you have no idea what the regression is, stop watching the video and go somewhere to find out what the regression means, and then come back later to watch. You don't have to know all the details of the regression. You just need to know what it means. That's enough. Okay, let me start. I'm going to show you 4 TensorFlow regression models which are different but look very similar. This is model 1, model 2, 3, and 4. It was fast. Don't worry, you'll understand everything. The first thing we can notice is that every model consists of 3 sections. This is the first section. The keyword here is sequential. The second section, the keyword is compile. The third section, and the keyword is fit. Take a look at the models again. 3 sections, 3 sections, and 3 sections. Going back. Now focus on the second section only. Did you notice that every model has exactly the same compile section? That means even with these different regression models, the way the models try to find their optimum is still the same. Of course, you can use different loss functions or apply different optimizers, but that's not the point in this video. Since we know that all models have the same compile section, let me make it short to have some more spaces on the screen. We'll go into the compile section later. This is a modified version of model 1. You can see the usual name for this model, simple linear regression. The first line is added to define the horsepower variable, which is just one column of the given train features dataset. Can you guess why this model is called simple linear regression? The reason is that there is only one x variable. How do you know that this model has just one x variable? You may say that that's because the horsepower variable is defined as just one column from the dataset, and that variable is used in the fit section as an x variable. That's a good answer. But the more obvious way to see that this model has only one x variable is to notice that the input shape of the first layer is 1. This is not a mistake, it's a tuple notation. All TensorFlow models need to know the input shape from the beginning, and the simplest way to handle this is to specify it explicitly in the first layer, saying that the input shape is something. To compare, let's move on to the second model. The usual name of this model is multiple linear regression. We can see that from the input shape argument, which is 9. Also note that in the fit section, the whole dataset is used instead of horsepower in the position of the x variable. How do I know that there are 9 variables in the dataset? Well, that was given. The y variable is train labels, which is also given to us. Now it's time to introduce the normalization layer. Why do we need the normalization here? You'll see why we need this layer in the practice session. For now, we just assume that we need it. Suddenly, the input shape argument is gone. How do you let the model know the input shape? First of all, the dense layer is not the first layer anymore. It takes the output of the previous layer as its input. So we don't have to worry about the input shape of the dense layer. Then how does normalizer know its input shape? It's here. Normalizer is a variable name of the pre-processing normalization layer. It's a pretty new experimental layer introduced recently in TensorFlow. Before the introduction of this layer, we have to do the normalization manually. Now that we have the normalization layer, just call the layer and put it in a variable name of your choice. Then one more line of code. Put the data to be normalized with the keyword adapt. That's it. It will do all the housekeepings for you. Since we put the data in the layer, it knows the input shape by itself. Also note that there is no change in the fit section, because this model uses all 9 x variables in the train features dataset, and y is still the same. Before we move on to deep neural network, let me mention the role of the units in the dense layer. When you have a dense layer, we don't need to specify the number of inputs to the layer unless it is the first layer. But we always need to specify at least one number, which is the number of outputs from the layer. That is units. Okay, the last model, deep neural network model. It has 3 layers. If you want, you may add much more. There is no implicit argument, but we know that the normalizer has the relevant information. All the outputs from the normalizer layer will go to the first dense layer as inputs, and the first dense layer will do some jobs with the ReLU activation function and produce 64 outputs. Then these 64 outputs will go into the second dense layer as its input, and the second dense layer will do something and produce only one output.